Okay.
I will continue doing some chemistry then.
How's it going?
Hey, good.
Austin, what's up?
Oh, nothing much. How are you guys?
Pretty good.
Good. Okay.
So Jonas. Oh, just kidding. Give me food. Okay. Oh.
All right. So we're live.
Yeah, it's
Do
recording.
this. Do you guys have any questions about the preparation assignment? Julie,
The
do you have
only
any
one
questions?
I had, where did it go? I wasn't sure how to do number 3B.
Okay, let's look at it.
Don't know how to find that.
3B was asking for
40th
the
percentile.
40th percentile.
Find-
Oh, okay.
So you would have
So
to
you go-
plug it into that thing, right?
That's what I did.
Yeah.
So when you plug it into things, you just put 40%?
Well,
Yeah,
At the
you go to
top?
the top.
40.
0.40.
Oh, I wonder if I just put
And that will give you the z-score.
for okay. And does the whole thing need to be highlighted or not?
No, it says the 40th percentile, so you just want to highlight to the left.
And then you type in
0.40.
okay.
Yep. Then
So the z-score is 0.253.
okay, yeah. So then you multiply that by the standard deviation.
So times 5?
Yes.
Okay.
And then you subtract that from the mean.
Okay.
So all these calculations are based off of that equation of the z-score equation.
Oh yeah, the value minus mean over standard.
Yeah. So you're basically doing it backwards.
Okay.
Because you have the z-score. You find
Okay.
the z-score by plugging in the 40, and then you multiply by the standard deviation instead of dividing to get the
Find the
value.
z-score, and then you solve
Yep.
for the value.
Yep. So you're just switching around the variable that you're solving for.
Okay, that makes more sense now. Cool.
Awesome. You have any other questions, Julie?
I think that was it. I think I got
Cool.
the other ones.
Riley or Austin, did you guys have any questions about the preparation assignment?
Nope.
Nope, me neither.
Sweet.
Should we go to the quiz?
Let's do the quiz.
Sure.
Yeah?
Yeah.
Okay. Okay. You guys all there?
Yep. Let's start on number 3.
Yep.
And then we'll come back together when we've figured it out. I'm ready when you guys are.
Me too.
Oh, which would you highlight though? I'm trying to.
The middle.
Okay. Let's make sure that I'm just doing it right. Okay. Well, I got 0.825. Well, 826 if we're rounding.
Yep. That's what I got.
Me too.
0.826.
You get that, Julie?
35. Right, total. At 0.19.
Nope.
Oh wait, that didn't type in. I typed in a z-squared, but that changed that. 1.358.
Mm-hmm.
So 0.82 or 0.83.
So
Well-
we round to the third.
Yeah.
Oh, to the
Decimal.
third.
Yeah.
Okay.
0.826.
26.
Yep.
Okay, cool.
Nice. Question 4.
Which of the following would have a smaller standard deviation? Line observation. Is that the sample means? I'm trying to remember these.
Which sample?
Well,
Because isn't it the more samples that you have, the smaller the standard deviation gets? I don't know if that applies to the.
well, if it's, let me look it up.
I think it's the individual observations.
You think so? Where? Why would you say so? Just because I don't understand.
So I just made up some values for the mean and the individual value and the standard deviation, and I calculated the z-score for both the sample mean and the individual value using the same numbers, but with the two different equations. You know how it's like standard deviation divided by the number of sample size,
Right.
and I got the z-score of the sample mean was a lot bigger than the individual.
Oh,
So I would say that the distribution,
of the individual observations.
a smaller standard deviation. Yeah.
Okay, I think I get it. Does everyone else understand that?
So it's individual.
So
That's what I
sample mean
think.
could be a larger standard deviation.
That makes sense.
Oh,
that
is it
right?
because there's more things, so there's it has to be larger in between because there's more things. I don't know. Okay.
Okay. All right, number 5. Which of the following results implies that the spread in the sample means increases as the sample size increases?
Central limit? Or is it the law of
remember that
large
from
numbers?
last time. The central limit theorem. It's the as it increases.
Oh, it would be,
Wouldn't that be it?
yeah, the central limit theorem. Because, like,
that
in
makes
this prep, question 12, I have that too.
Oh. Well, I think it's C. I think it's the central limit theorem.
Yeah, that's what I think.
I thought it was the law of large numbers.
Really?
Yeah.
written down so I can sneak around me.
And I could be wrong about number 4. I don't want to lead you guys astray. Feel bad. I don't.
It's okay.
To
I
be
didn't
honest-
understand it, so I'm trying to find
Okay.
it on the
I just
thing.
want to let you guys know that I do not feel 100% on that answer.
We can come back to it.
Okay. So number 5, you think it's the essential limit theorem?
I can't remember. I like looking at the videos where that instructor, not the guy that like writes it on the chalkboard, but the like instructor that walks through the PowerPoint explains it, and I'm trying to find it.
Do you guys know what the difference is between the essential limit theorem and the law of large numbers?
I used to. Now I don't.
I forgot.
I'm trying to find it.
Well, this is really Christmas for herself.
I think
Oh, this is the law of large numbers. The greater amount of observations in our sample, the sample mean draws closer to the population mean, or as the number of repetitions increase in the experiment, the proportion of an outcome observed gets closer to the probability of the outcome. So let me see if I can find the central. Okay, so the central limit theorem, from what I found, says as the sample size increases and becomes large, the distribution of sample means becomes approximately normal. So that's the central limit theorem. So,
Okay.
but I don't know if that's the central, because it says, which of the following implies that the spread decreases as the
Spread.
sample size increases.
also if the sample size is increasing, then it's saying that the spread is decreasing. So wouldn't that mean that the standard deviations are decreasing too because they're getting closer?
Like the bell becomes like thinner and
Well, like because if you look on the prep assignment in question 11 and then 12, when it says that the right's skewed, but the sample size is 40, definitely normal because there's a larger sample. And that was
So
because of the
that's.
central
I think
limit.
the essential limit theorem has to deal with being normal or not normal or skewed.
yeah, that's what the central limit theorem is at this.
But this one has the question doesn't ask anything about normal or skewed, so that's why I thought it was a lot of larger numbers.
Yeah, I agree. I found that the law of large numbers states that the sample mean will be close to the mean.
That's the large number one.
Yeah, and it says this happens because the standard deviation will get smaller.
Okay.
Yep.
That sounds.
Okay. So the law of large numbers,
Yeah.
Yes.
4 or 5. Okay.
Moving on.
We can come back to 4 later.
Okay. I like that.
Use the following info to answer the next 4 questions. So this isn't the one where we have to like find the square root of something. This is just finding the z-score, right?
The only time you need the square root is if it gives you the sample size, right?
Yeah, that's what I was just clarifying.
I think so, yeah.
What did you guys get?
1.045.
Yep. Did you not get that, Julie?
Oh no, that's what I got. 0.04.
So did you guys get 0.852 for
I got 8.
On what?
Wait for the probability.
yeah.
You're on 6?
I'm on 7.
Oh, I got 0.148.
That's what I got.
Same here.
Oh, for which one?
For 7.
Number 7.
Oh, never mind. Oh, above. I see now what I did wrong. Okay. 0.148. Yeah, I got you now.
Okay.
So for 8, we find the mean of this, and then we use the sample size for that one equation, right?
Plus 1.
Yes, now is the sample one.
So it gives you. Wait, so. Oh, so we go back and use the other one.
Okay, what did you guys get for that one? Or not?
So I don't know if I did it right.
I got
I
2.338.
Me too.
0.38?
2.3.
338.
Oh yeah, it's 3 decimal places. Yeah.
I got the same thing.
Did you get that, Julia?
Yeah.
2.338. Okay.
So higher than the C score for the next one, right?
I'm ready with number 9.
Did you get 0.0097?
Yep, that's what I got.
Yeah.
So do we round it to
Number.
0.01?
No, it actually
It's
it says 4 decimal places
Oh,
in the
on
question.
this one?
Yep.
Okay.
0.0097.
Yep.
Okay. You guys good?
Yep. Question 10.
Suppose the mean.
So, would it be approximately normal?
That's what I said.
Yeah, me too.
Yeah.
Awesome. Number 11.
So we're trying to find. How do you do this one? Oh wait, isn't it the? What's the mean of the sample mean? Doesn't the mean stay the same?
That's what I think.
I think it's 3.5.
Yep.
Because it's still, yeah,
Yeah.
tricky.
And also the standard deviation, the same. For question 12. Yeah, 12.
Oh, yeah, it's like the same question.
For 12. Wait, for standard. Okay. Or do you have to divide it by the square root of 81 to get the standard deviation? For all the random sample.
Oh, is that
I thought
that
that's,
I
or
don't
is it
think
just
so.
the same?
Thought it was just the same.
Okay.
I don't know. I'm gonna do it that way, but I can't remember. Yes. Yeah.
It says round your answer to 3 decimal places. On question 12. I'm assuming it's 3 decimal places. So you might be right.
Yeah. I just can't remember, but I think so, but I'm really not sure.
I'm not.
I don't even know where I put my notes from the last one.
Because when I took 0.7 divided by the square root of 81.
Well, I think it is.
0.077.
I got 0.078
I mean, I don't know if it's right. I mean,
there, but I felt like on the last prep, only the one thing stayed the same.
yeah.
But sure.
I don't know.
Like 11, I think makes sense to stay, but 12, I don't think it. Especially because it says
Yeah.
round your answer with 3 decimal places.
Because I think in the last prep it said standard deviation equals the standard deviation divided by the sample size if there's a sample. I think. I'm not like looking at it.
Okay.
So for this one,
Deviation of the random variable is the standard deviation over the square root of the sample mean. I'm gonna sleep already. Yeah, you're fine. I don't know. I would go with your guess, but I don't know. Anybody else have any ideas?
Well, could you explain what calculation you did to get a different answer than really get the answer that you got?
Well, from what I'm understanding of Julia is that you take the standard deviation divided by the square root of the sample mean, which the sample
Like, okay, so
size is
I'm
81.
on text that we read for today on my phone, and then like at the end, a review of it says the mean of the distribution of sample means is the population mean, so the original one, and then the standard deviation of the distribution of sample means is deviation
The
divided by the square root of n.
Yeah.
It says the standard deviation of the distribution of sample means is standard deviation divided by the square root of sample means. Makes sense. It's like that weird circle thing over square root of n. Is there.
Okay.
Does anybody else have any other ideas? Or I think that could be right, but I'm not like positive, you know.
Well, because if you even like look on,
Yeah, I see where you're reading, and I think it makes sense.
yeah, or on the bottom of it when it has the whole standard deviation, it's equal to that over n.
Mm-hmm.
Yeah, I agree. I found it too. It says the standard deviation of the distribution of sample means is sigma over square root of n, where sigma is the parent population standard deviation and n is the sample size.
Okay.
Okay.
Cool.
Okay,
Should be 0.078.
that's what I.
Yeah.
Okay.
What's the probability? Less than 3.
So now the question is, do we use that standard deviation to do this calculation, or do we go
Yeah,
back
that's
to
what I
7?
did. I think you always use it if there's the sample sizes given.
Yeah.
81
Okay.
sample size, and you don't.
So it'd be what, 81 minus the or 3.3 minus the 3.5
Yeah, that's what I did.
divided by the 0.7 divided by the square root of 81. Am I on the right track?
Yep.
Yeah, 0.7 divided by.
You. Got negative 2.57.
For the z number.
Score.
Oh, that's not the probability.
And
then the probability is 0.005.
Mm-hmm.
Yeah.
Yep.
So low.
Okay. Yeah, it's very low.
And then 14 should be the same because it's just greater.
Oh, we just put that same thing,
Yeah.
but
So it'd be 0.995.
0.005.
0.995.
For the other one.
Or wait, greater than
Is 0.9.
0.9949, so 0.995.
Yep.
Why is this one really long? Okay. Nice. So mean.
I'm ready. I got a 0.9726.
The sample mean. Sorry, I'm still.
So is it the sample mean minus, so like the 177.6 minus the 185 divided by the others?
Mm-hmm.
Yeah, because there's the mean weight and then the sample mean. Okay, so it's kind of like that one other.
I just want to make sure I'm doing it right.
Mm. And then, so there's 40, so is 0.7 divided by the square root of 48 underneath. Okay.
So we're talking about
Probability.
above or below?
No, just below. Oh, sorry, just above.
Just above. So it says find the
what?
probability that a random sample of passengers will have the weight that is as extreme or more extreme, either above or below the mean that was observed in this sample. So would we click above?
I think so.
Well, that's what I'm trying to understand.
It's kind of weird.
That's confusing to me.
It says
That's
note as
confusing.
extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction. I don't understand.
Okay. Find the probability. Extreme or more extreme. Why can't they just say more?
Oh, it'd be the bottom. Just highlight the tails, not the middle. I think that's what it means by extreme.
Oh, that makes sense. Because you want the highest and the lowest.
Oh, above or below the mean.
Yeah.
So
That's
Okay.
0.055.
That's what I got.
0.0.
0.0.
0.055.
Yeah.
Okay.
0.05.
And you got the z square that you guys plugged in was negative 1.92.
Mhm.
Yeah.
Awesome.
0.5.
0.055. Okay, back to number 4. I've been thinking about it in the background. I think I understand it now. I want to switch my answer to
Okay.
the distribution of the sample mean is smaller. Because
Okay.
Right. So just think about it. This, I guess I'm trying to explain it, put it into words, I thought.
Yeah.
So like individual distribution means that they're all comparing themselves to the mean. But if you have a sample mean distribution, that means that all of those numbers have to either be extremely low to have a low distribution, or that all those numbers in that sample have to be extremely high to have a high distribution. So that's really unlikely to have all of the sample being high or low. So that means that the distribution of a sample mean is going to be like really close to what the population mean is going to be. So the standard deviation is going to be like super low, a lot lower than like an individual basis, because there's a lot more variety talking about individuals. That makes sense.
Okay.
That was my thought and why I changed my answer.
If not, this one said that we have 2 attempts on it.
Oh,
So we
sweet.
can always take it back.
Yeah, we do.
So I'm putting sample means. I keep thinking that we only have like one
Mine
attempt
too.
on this.
That's what I thought on the other ones too. And then I was like, saw that. I was like, oh,
All right.
that's weird.
You want to go through them again, make sure you have the same answers, or are we good to just turn it in?
Let's just turn it in.
Okay.
Yeah.
Like a band-aid.
Limit by equals, yes.
Oh, I missed one.
No, I missed one too. It's the last one.
The
Was it
last one? What? I didn't miss the last one.
Oh, I typed in the last one wrong. 0.55 instead of 0.055.
I got question 3 wrong. I don't know why.
Question. I might have gotten that one wrong too. Oh
Yeah,
yeah,
that's what I got wrong too.
I
So
got it wrong too. What was 3?
use the normal probability applet to find the combined area under the standard normal curve to find the right of
To the right of.
and to the left of. Oh,
Did we not combine those 2 things?
do we not put?
Oh, we're supposed to find to the right and to the left.
Yeah. What did we do? Oh,
Instead
did
of
we
the
just do
middle.
the middle?
Oh, we highlighted the middle.
So we're supposed to do the tails, right?
So right and
okay.
left for that one. And then the last one. I just typed it in. Did you guys get the last one? Or?
I got the last one right. The
Okay.
only one that I got wrong
Okay.
was that one.
Okay. I just need to type it in right this time.
Are you guys doing your second attempt?
Yeah, I'm just gonna write this all down before I do.
I just duplicated my thing.
What'd you do?
I just, in Chrome, I can just duplicate my tab.
Yeah, I'm just gonna open up another one.
Did you guys get 0.75 or 0.175?
Wait.
Sorry, I'm almost done. Yep, I got 1745.
So 3 decimal places, so 0.175.
Yep. Mm-hmm.
So number 3, 0.175.
Mm-hmm. Number 4 was the sample means. Number 5 was the large numbers, right?
Yeah.
Okay.
Number 6.
I just submitted it.
How'd you type in all your answers?
So speedy. Question number 6 is 1.045.
1.045. Okay.
Yes.
Question
6 is
7.
1.045. Question number 7 is 0.148.
148.
0.148.
Question number 8 is 2.338.
2.338.
Question number 9 is 0.0097.
0.0097.
Yep. Question number 10 is approximately normal.
Okay.
11 is 3.5.
Wait, it's 1.3 358. What was it?
8 is 8. Question number 8
Oh,
is
wait, no.
what?
11.
11. 11 is 3.5.
So 12 is
12. 078.
0.078.
Yes. 13.005. 14.995. 15 is 0.0. True. Question number 3 is 0.175. Question number 4 is the distribution of the sample means. Question number 5 is the law of large numbers. Question number 6 is 1.045. Number 7 is 0.148. Question number 8 is 2.338. Question number 9 is 0.0097. Question number 10 is approximately normal. 11 is 3.5. Number 12 is 0.78. 13 is 0.005. 14
Wait,
is
number 12.
12 is
0.0.
0.078.
Is it? Wait, it's 0.0.
Thirteen.
Oh, yeah, sorry.
13 is 0.005.
Yeah.
14 is 0.995. 15 is 0.055. Any questions?
Mhm.
Sweet. All right. Awesome.
Good job.
All right. See you guys next week.
See ya.
Yeah.
All right. Bye.
See ya.
Bye.